cosine, I'm going to tell you what it looks like, and then apply it to maybe a problem maybe, or even I think I have at least one triangle solved maybe somewhere on the law of cosines. Okay, so let's do this quickly, guys. Watch my time here. June, Mr. Park, this test is one that's going to require time. So I got to stop myself. Oh my goodness, it's 12:35. Let's see. 1 o'clock, 1:15. I've got to stop here 1 o'clock. Got to. Okay, here we go. Part one, yes. This. Now guys, myself, and you've been with me long enough, I don't like just throwing formulas at you and not showing you a little bit where it came from. I don't like that, but I want to do it this. Arena, can you tell me the first one start out with a squared equals? Okay. A squared equal to b squared plus c squared. Was it minus 2bc and cosine angle A? Ooh, I wish I had the time to show you where that came from. Another version, it depends on which version you want to use, another version looks like this. B squared is equal to a squared plus c squared minus 2ac cosine b. We're going to make sure I get these copied down correctly. And the last one could be written for another version here, like this. And cosine angle C. Are all those written down correctly? And they're called law of cosine. And it depends on what they're asking you to do and your work as to which one of those versions you want.
The last one is b squared plus a squared minus c squared.
Wait, hang on. A squared plus b squared here?
No.
Right here. Yeah. And minus 2ab. Is true?
Yeah.
Okay, cosine C. Everything else looks good? I'm looking at it a bit quickly. Everything else is good? Okay. Now, I'm going to apply one of these. I think that we have something there. Before I jump into it, without a derivation, can anyone tell me, of those three strange looking formulas, they call it law of cosines, which one looks most familiar to you from your math? Just math at this point, which one of the three versions looks most familiar to you?
The c squared equals a squared plus b squared.
This one, c squared is equal to a squared plus b squared, looks like that is something we've used in solving a what type of triangle? A right triangle. That's the Pythagorean theorem. Applies only to right triangles. And for a right triangle, that means this angle here must be, they're talking about 90, if it were 90 degrees. What's the cosine of 90 degrees if this were a right triangle? What's the cosine at 90, the x-coordinate at 90 on the unit circle? Is it 0? Would that force that to drop out? And then you're left with Pythagorean theorem. Okay, so if that angle C, well, it's a right triangle, right angle, turns into Pythagorean theorem. Now, here we go. Let's try one here. Given, I guess I'll put it like this, or did I have a triangle drawn for you, Arena, on that handout, or did I just give you some information?
No, just solve the given triangle.
Okay, now what was it, triangle ABC?
ABC.
Okay, now hang on. And what did I say about this triangle?
C equals 60 degrees.
Small letter C,
No. Big C.
capital C, 60 degrees?
Yeah.
Okay,
A equals 2, small.
okay,
B equals 3.
like that. Okay. And she says, Professor, you're just asked me to form a triangle that given and solve and find the missing parts. In other words, there's some parts here missing. Guys, let's make this look like it's an oblique. It could be a shape like this, who knows? As long as it's not a right triangle, I don't think it's going to turn into a right triangle. You label this the way you wish. We'll call this angle A, angle B, angle C. The way I have mine labeled, of course, my corresponding lowercase letters will go there. She gave me, Professor, this angle is 60 degrees. And side A has a length of 2, lowercase a. And B has a length of 3. Arena, so far so good. Okay. And that's what was given to me. Now they're asking you to solve this. In other words, let me go ahead and mark what's unknown. We gotta find angle A is missing. Looks like with what she gave me, angle B is missing. And it looks like side C, lowercase c, is missing. You step back and look at it. You guys agree? Now, I saw you yesterday. Did they give me enough to work with on this triangle to apply the law of sines?
No, for cosine.
Yeah, that's the trouble. That's why we had to have this law of cosine. I don't think they gave me enough to match things up and use the law of sines. You guys think so? If we start matching things up, now I'm sure you what I mean for you guys looking at this. Marina gave me 60. She said, Professor, yesterday you said take sine of 60 over C equal to, and then choose another and do a match for me. I got sine of 60 over C. That's perfect for law of sine. I need another. Now where is the other? Did they give me another angle to work with? No. Now can I assume these two angles are equal? No. They might be. I cannot assume that. So they did not give me enough to apply the law of sines. That's why you have the law of cosines. Okay, and I think your textbook does not show you there's even a law of tangents out there somewhere. Okay guys, let's apply the law of cosines. Here we go. Now you say, Professor, which of the 3 versions should I use? Well, she gave me A is 2, B is 3, angle C is 60. Which one might be the most appropriate with what was given to me of the 3 versions?
The third one.
That third one? We'll try the third one. Here we go. Now the third one says side C squared. I'll do that. A looks like it's 2 squared. B 3 squared. Oh, that's given to me. Subtract 2 times A times B. Make sure I put all these numbers in correctly. Cosine of, yes, she gave me angle C. That's 60 degrees. You step back and make sure you put all that in correctly. Did I put it in correctly, guys? Have you done all the numbers? Just applying the formula. Play around with this. You're going to end up with C squared is equal to 4 plus 9. I think all this together right here, is that 12? And then she gave me, thank goodness she did give me an angle that we should recognize. It says find the cosine of 60. And what is the cosine of 60? It's a half. Marina, if you give me cosine 40, you have to use a calculator. So even on your final exam coming up Thursday, when I give you one of these, I gotta make sure I give you something to work with like you did on this one. Guys, let's calculate this. This is C squared is equal to, what's that, 13? I think it's 13 subtract 6. See if I'm correct. Is that true, guys? And it takes the square root, you're going to end up with square root of what, 7? Strange number, but that's the length of that. You guys agree? Okay. Are we finished? We have side C. Are we finished with the triangle? Or is there something else missing? What's missing? Angle A and angle B. Now, I've had some students say, oh, Professor, I know all 3 angles just sum up to 180, and they gave me 60, so that leaves the other 2 to sum up to 120. Is that true? And then they split that 120 up between the 2 here and say, oh, the other 2 must be 60 also. So this is a 60, 60, 60 triangle called an equilateral triangle. You think I should do that? And just go ahead and put 60 here and 60 here and go on? No. So what should I do now in an attempt to find the size of those missing angles?
Low sum.
Now, can I jump into law of sines from yesterday? A little risky, could be a little risky, because if we missed this, we made a mistake here, we placed it on the triangle, and then I apply it later on in law of sines, I may miss the law of sines also. Let's hope we did not. I ain't gonna apply the law of sines here, guys. Here we go, let me erase this. So I think students are saying, Professor, law of sines would say sine 60 over this square root 7 that I just discovered, and let's hope that's right. Now give me another match here I can work with. Sine 60 over radical 7 equals, how does the law of sines work? Sine what with what? Oh, sine B? Okay, sine angle B, you can do that. And that's over what? 3, side B. And there's the law of sines. So after I use the law of cosines, I could go into the law of sines, a little risky, but we're doing it. Guys, we'll do a quick cross multiplication. This is 3 sine 60 equals radical 7 sine B. June, I may need your help here in just a few seconds here. Guys, we'll divide by square root 7. Square root 7. Not let me make a mistake on top of the board up here. Now, sine 60, remind me what sine 60 is? Is that radical 3 over 2? Is it sine 60? So about 3 times, I could at least put that in before I ask June to help me out here. Radical 3 over 2, look at this mess, over square root 7. What a mess. Has everything been put in correctly so far? This sine 60 radical 3 over 2. Clean this up the best I can. Not much here. Guys, on top I have 3 radical 3 over 2. And in my denominator looks like it's a radical 7. Oh Lord. Now you're going to end up with 3 radical 3 over 2 radical 7. I'll just clean things up. Now what would you suggest I do to clean up, simplify a little longer before I ask June to approximate for me? If you rationalize the denominator, multiply by radical 7. I'm just going to do radical 7. Now, on top here, that'd be 3 radical 21. Bottom part should be nicer, well, it's somewhat nicer, it's 14. Is that true? What a mess. I think it's messier. We're not finished. June, I hate to ask you to do this on a Friday. Could you go ahead, could you go ahead and do an inverse cosine? Was it sine or the inverse sine? Do an inverse sine on this mess and see what on earth is angle B close to.
It's 79.11.
79.11 degrees. Oh, Lord, that's angle B. Now, if we feel good about this, could we find the missing angle? I think it's angle A. Quickly, if we feel good about our work. Now we get what? Sum these two up and subtract from what? 180? All three should sum to 180. Go for what?
40.89.
How much?
40.89.
40.89. Don't mess up there.
Everybody's checking.
I'm checking it right now. Guys, is he right? Is it? Thank you. We have the triangle finished. There. Now, are there some triangles out there that I can give you measures and you do whatever you can do and you work all day? And just so happens the measures given to you would never form a triangle. Yes. You could run to a no solution. Okay? This one will work out nicely. Before I leave it, the way I remember the law of cosines, if you need it, if you start out with side A, you end with angle A. course, cosine's what they call all cosines, cosine in all versions. If you start out side B, you end with angle B. Side C, angle C. That sort of helps you keep in mind what goes where. Okay. Now, Rena, I doubt if I have time. Was there another one there, or was that the only one they asked us to solve, or I asked you to solve?
Only this one.
Just that one?
Questions, yeah.
Okay.
And she-
And then we're going to do the shaded region. That'll feel good. Do the shaded region, guys. Here goes. I don't think I had this on the grid. I just had, what, a circle, was it? Okay, here goes, guys. Okay. And what did I have placed inside there? I was trying to remember what I asked you guys to do. Let me see right quick. So I get this done. Well, I got a 70-degree angle inside here. Something like that. And I did this. I think I just want to close this down today. I put 8 feet is the length of this radius. Then I had this shaded. Okay. I think I saw something like this in your textbook. Also, I saw one like this on the placement test. College. Make sure, when you look at the board there, make sure I have everything written down for you. Is that the way it looks? Now, any ideas? Close down today. You're looking for the area of that shaded region, and you have that to work with. We got a reason through it. It's about area. Read it.
We can know the area of full circle.
Thank you. Let's do the area of the full circle first. Nice. Guys, the area of the full circle, area formula was it pi r squared?
Yes.
Thank you. Radius is 8, so that much will be pi, what, 8 squared? Then you're going to end up with 64 pi, you've got partial credit already. And that's the full circle. Yes?
We can assume that that line is from the center of the circle.
And that, thank you. Yeah, this is what we are going to assume that is the center. If it weren't, we'd be in trouble. Okay, glad you brought that up. Now, keep in mind, the aim is to get to that shaded region. So you got a little partial credit already. Now, what else did you do?
So the length of the part that is shaded, I mean, of the circle.
Up this up here?
Yes, is the twice angle in the center.
Okay, hang on.
Halfway.
I think you're trying to think of a ratio. It's a piece of the circle.
Yes, yes.
Is that right? Now, I think, guys, he's telling me this. He says, Professor, all this, the shaded and the triangle, all that is a piece of a ratio of the full circle. Is that true? And that would be all of it, all this right here. What ratio is it? How would you find it? I need a ratio of the full circle. He gave it the full circle. We have the full circle.
It's 360 minus 7.
Get close.
Oh, okay, 64 pi.
You're the one who brought it up, and that's exactly what we need here.
Well, would it be 70 over 80?
Oh, Lord. Gee. 70 degrees, she's exactly right. And how many degrees are there in a full circle? Is it 360? No, not 180, is it? Is it 360? Don't skip it. Is it 360 for a full circle? Gee, it says, oh, Professor, come on now. Compare 70 to 360. That's your ratio. Of the full circle. And the full circle was given to me back in step 1 as this. Now, this is going to be madness here, guys. Jude's going to help me out here shortly. But that would show the ratio of the full circle. that true, guys? Okay, June, let's do this in little pieces here. Oh boy, here goes. Could you calculate that for me?
70 over
360,
mhm.
and then times 64 pi. Gee, that's genius.
It's 39.10.
39.10 for that.
Mhm.
Gotcha. Now, that's not what we want. We want the shaded region. Right now, a little reminder, we have this. We don't want all this, we just want that little piece there that's a shade for us. So I need to do more thinking here. Let's get through here. What else might I do?
We need to find the triangle.
The area of the triangle.
Yes.
Okay, this triangle right here, guys, and we find its area. And what might I do after I find it?
Just take it out.
Take it out or subtract it from what Gia helped me out with here. And what's left has to be that little piece shaded. Is that true? Does that make sense? So let's find the area of the triangle.
We need to make an H.
Hang on. But I need the area of that triangle. Guys, we're gonna do this. So I'm using this color. I'm trying now to find the area of that.
Yeah, we can make a height of triangle.
Well, you know what? I could drop an altitude or a height and go through that. But did we not come up with like a little formula for the area of a triangle the other day when in fact, I think I used it to do the law of sines. Does anyone recall how to find the area of a triangle? And I kept saying those kids across the street don't use that formula, but yes, yeah. Okay, now 1/2 base times height is exactly what they do across the street, exactly. But we did something a little bit better.
So 1/2 C
Hang on now, 1/2.
sides.
Okay, you choose two sides, right?
And sine of.
Now, by the way, this side was marked with 8. I'm assuming this is also 8, another radius. So it's 8 times 8, there's your two sides. And what else?
And sine of.
There you go, sine of the included angle. And what angle is included between? 70. Wow, what a beautiful problem to close down with. Now that's what we were doing yesterday. You guys were with me yesterday. That's how we find the area of a triangle. June, I'll clean this up a little bit the best I can. It looks like it's like 32 times the sine of 70. Could you see what that's close to?
Sine 70
How much?
is 30.07.
30.070?
07.
Oh, 7. Guys, we got that. Oh boy, I see the answer coming out. Do we follow so far, guys? Now, what should I do now to find what they really wanted? And that's number 4. They want the area of that little shaded region. And you guys, I think, tell me what to do there. What am I going to do?
It's 9, 10 minus.
I assume 39 point, what was it, 39.10? And you must subtract from that 30.07 that she gave me.
9.03.
What's that close to?
9.03.
Beautiful. There's the answer. You guys are doing well at Math 7 after all this. Guys, any concerns here on this? Make sense the way we approached it? So you find the area of this little piece of that, I'm going to just logically go through it with Gia's help. Okay, sure enough, here it is, 1 o'clock. We're supposed to take a what, a 2-minute break? Oh, I thought it was. Okay, we got 15 minutes.